Welcome to GRE Bytes. My name is Davis. I'm an educator with over 10 years of experience.
And I'm Orion, the founder of StellarGRE.
We're here to bring you another weekly bite-sized episode on GRE prep and grad school admissions. For more information, check us out at StellarGRE.com. Okay, so we've talked about different sections, and one is the quant section, which is often what gives people a lot of anxiety. We've talked about different tools. I'm interested today specifically to pick your brain about when you have the type of quant question that gives you variables, and rather than getting an analytic solution where you're like a general solution and solving the equations, it's much simpler to just plug in a few different numbers and hone in on one of the multiple choice answers quickly. In that kind of situation, what are the go-to numbers when you're just like plug and play and you want to get?
It's a great question. Let's start with the first thing that you alluded to, but I want to make sure that everybody understands what you're talking about,
Sure.
because some people might not. So there's a lot of algebra on the GRE, and in the Stellar system, we try to forego 99% of all algebra. Why is that? Because algebra in most cases is abstract. It's kind of infinite, because an algebraic variable can represent in many cases an infinite number of values. Which doesn't give students great odds. If you try to solve questions algebraically, you kind of have to derive the one correct value out of the infinity of incorrect values in order to get that point. Not a great path.
And the only way you can do that is by understanding in depth the equations that are in play in the problem, and then solving it analytically to find that specific value.
Yeah, algebraically is what I would say.
Yeah.
And the other reason why I don't like the algebraic solutions in general is that I've yet to encounter a person who is more accurate and more efficient with algebra than with arithmetic. Even the biggest math hotshots that I have tutored in my time, and I've tutored several of them who knew way more about math than me, and some of them were committed to doing it the hard way, they still couldn't beat me on the GRE quant section on some level, because over a long enough timeline, over 4 hours, over hundreds of questions, they're just slightly more likely to make a careless mistake on the level of abstraction using algebra than the level of concreteness using arithmetic.
And this points out something that has been a source of frustration for me, but is understandable in the context of the GRE test, a standardized test in general, which is the test is not, it's not after your innate or intimate knowledge of the math.
No.
At the core of a question.
Correct.
It's after your ability to recognize a problem, solve it quickly and efficiently under time in the scope of the larger test.
Yeah, it's not really a math test. Like if you get to a certain level, it's like Neo at the end of the Matrix. You can see the code. You can kind of see through it. Math is the means by which they are attempting to assess an aptitude, which is a general ability basically. But they have to do it in something. They can't just scan you for general ability. Like, what does that look like? So on some level they use words, and that's the verbal section. Some level they use quantitative concepts and numbers. That's the other section. So, but those are just like a means to a greater end. Now, how successful the GRE is in assessing that general ability is another question, and in many respects we know that there are some significant failings in that assessment, but it's not a completely terrible tool.
And so back to the question at hand, which is we understand the GRE is not testing a person's, can't actually assess a person's ability to understand and recognize the math at the core of a question, because at the end of the day, it's just whether you got the question right or wrong and how much time it took you.
It's not even about that. It's like you can do the question right and hit the wrong button. Sometimes what I tell students is the GRE is a button-pressing task, and the only thing that matters at the end of the day is you push the button that gets the credit.
And so even if you're a math whiz, there are certain strategies that can help you be much more efficient, use less mental resources, and therefore be less prone to hitting the wrong button. Keep your field clear so that you're just honing in on the right choice with the mental capacity to still just click the right button and move on to the next question. So one of these is, instead of solving it algebraically and understanding the math at the core, you can solve it arithmetically with arithmetic to hone in on a multiple choice answer or even
Could be multiple answer too.
Yeah.
So that's absolutely correct. So rather than do the algebra, we're going to do arithmetic instead. And we can do that by plugging in our own values. And plugging in is like the staple technique of most test prep systems. So I don't think I invented it. I don't know if anybody invented it. But it's the bread and butter. It's the most useful quantitative technique on standardized tests because
you have a calculator, so
you do have a calculator, and it's the most useful technique because about a fifth to a quarter of the questions on any given set will be amenable to this technique. We know that they're going to be amenable at a glance. In the Stellar system, we call it structural diagnosis, where you try to figure out the way that a specific question is being presented. And the easiest way to figure that out is to look at the answer choices. And frankly, if there are variables, letters, for the most part, in the answer choices, you know that you can plug in. Plugging in works because, remember, an algebraic variable represents every value in a specific domain of numbers. And so if that variable represents every value, then any value that we choose will work because any is always contained in every. So we don't have to really worry about it so much. So by plugging in concrete values, we can transform abstract algebra into concrete arithmetic, and then just generally add, subtract, multiply, and divide our way to an answer.
And so in doing that, I'm imagining, and it serves a lot more to pick really simple numbers that make the arithmetic really simple and give us a direction to choose the next number if we're going to plug in more than one.
If we are, because we don't always do that,
That's
right?
right.
So
what are those numbers?
You're absolutely correct. So if we're only plugging in once, or for our first round of plugging in, if plugging in twice is indicated, we want to use the nicest, easiest numbers that there are. Because the test is hard enough. Why are we going to go out of our way to make it harder on ourselves? So the nicest, easiest number that there is the number 2. I love the number 2.
So real quick here, because why avoid 0 or 1?
Because they're weird, and that's going to come into the second round of plugging.
Okay, there we go.
0 and 1 are very important numbers for us, but they're important because they do such unusual, unique, and unexpected things in arithmetic. And so they're unlike really any other numbers that exist. So we'll get to that in a second. But 2 is the best number to use because it's small, it's even, we use it all the time. Because it's a relatively low magnitude number, calculations can go fast and accurately. So if you can, use small positive integers, 2, 3, 4, etc. if you have multiple variables. Now, if you have variables in the answer choices, but it's a choose one problem, which they call problem solving, so there's 5 options, only one of them is correct, then a lot of times you can get away with just plugging in once. You plug in numbers like 2 or 3 for the variables into the question, you solve for that, and then you realize that the answer choices are really just that target number in disguise. You can plug the numbers into the answer choices to transform them into values, and then you choose the one that matches up with the number that you're looking for, more or less, right?
Yeah, no, that makes sense to me. And if anyone wants to understand this more in depth, it's best to get your hand on some practice questions and sign up with GRE to understand how this works in principle. But if you already know what we're talking about.
With StellarGRE, yeah. I mean, the great thing about Stellar is that it's a very, very regimented system. It's like there is a protocol for every question on the entire test. And if you recognize what kind of question you're dealing with, then you just activate protocol and you kind of do what you've rehearsed.
This guy's going to make you Neo. I'm going to see all the code behind it.
Something like that.
Stop bullets.
I mean, a lot of the test is about realizing how the test is attempting to trick you and misguide you.
Yeah.
And if you can just, if those attempts become invisible to you through your training and your rehearsal, so much the better, right? Okay, so back to plugging in.
Yeah, so you plugged in the first 2, for example, 2, 3, or 4. If it's a single answer, you match it up, boom, you got your answer, you're done.
Yeah.
But
sometimes there are questions with variables and answer choices that are choose many. These are multiple answers, which are kind of choose all that apply, or in my system, quantitative comparisons. Technically, you're only choosing one, A, B, C, or D for quantitative comparison, but I like to think of quantitative comparisons like old-timey scales. So the pans can go up and down. This one could be heavier, this one could be heavier, could be the same, could be more than one thing. So in my system, quantitative comparison questions are considered multiple answers. For these questions, it's imperative always, always, always to plug in twice.
Mm-hmm.
Why is that? Well, if we plug in once and we get an answer, we haven't really proved that it has to be that value, that has to be correct. We've more or less demonstrated that it could be that. It could be this. It could be true that A is the correct answer. It could be true that quantity B is larger, but we haven't really conclusively demonstrated that it is true.
Mm-hmm.
So if possible, we want to stress the system. We have a tentative hypothesis, but if we keep plugging in nice, easy numbers, 3, 4, 5, we're unlikely to get a different
Conclusive
result.
answer,
Yeah,
yeah.
they're too similar in nature.
Mm-hmm.
So for the second round of plugging in, it's really important to try to stress the system as much as possible, because if we stress the system and it breaks, great, we know what the answer is. The answer is D on a quantitative comparison question. And if we stress the system as hard as we can and we still get a consistent result, that's actually still not proof, but much more convincing evidence that we've hit upon the correct solution.
Mm-hmm.
So not every number is going to stress the system. We want to use numbers that are weirder than other numbers because they're more likely to provoke something that is unexpected or different.
Mm-hmm.
Does that make sense?
So give me the weirdest number you're going to use.
Yeah, so we have a list of 5. I've rank ordered them. And 1 is more than 2, more than 3, etc. So we can just kind of go down this list in a mechanical fashion when we're plugging in for our second round.
Mm-hmm.
And you've already mentioned 2 of them. So the weirdest number of all is 0. That is a freaky number, dude. It's the valueless value. It kind of doesn't really make sense.
Breaks math in a lot of cases.
And a lot of the identity properties, dividing by 0,
Yeah.
the calculator will blow up. Anything times 0 is itself. There's a lot of weird exponents and arithmetic things involving exceptions that involve 0,
Mm-hmm.
right? So if you can use 0, always use 0 because it kind of destroys math and it's very easy to use.
Yeah.
Number 2 is number 1, also because of its identity properties.
Mm-hmm.
That's weird and annoying for number 1 to be number 2, but
And then after 0 and 1,
it's numbers between 0 and 1, which sometimes people call fractions or decimals, but as a
Mhm.
math nerd, I'm here to say that that's technically not accurate. Like the number 2 is a fraction, it's 2 over 1. The number
Mhm.
2 is a decimal, it's 2.0. And those aren't weird numbers.
Mm-hmm.
We decided that 2 is actually the nicest number that there is.
Mm-hmm.
So numbers between 0 and 1 are often expressed as fractions or decimals, but it's not that expression that makes them weird. It's the fact that they live between 0 and 1 on the number line. It's like a haunted neighborhood. They're good numbers, but that hood just makes them do weird, spooky stuff.
Right.
Mostly with exponents and radicals and things like that. They move in the opposite direction of all other positive numbers. Number 4 are negatives, mostly
Mhm.
because people forget about them.
Mm-hmm.
We like to use positives because we deal with positive quantities in real life,
Mhm.
and we're more fluent with them in our calculations. And number 5 is what I call pushing the extremes, which means
Go big.
either really, really big or really, really small, depending
Mhm.
on the context of the problem. And this one's number 5 because you can, even if you can't use the other 4, you can always, always, always push the extremes, because big and small are relative terms that are
Mhm.
dictated by the question itself.
Mhm.
So there's, even if it's like numbers between 0 and 1, well, a really, really big number could be 0.99 and a really, really small number could be 0.01. So you can
Mhm.
always find something that's big or small in a given domain.
That's right.
So those are the 5. Again, it's 0, 1, numbers between 0 and 1, negatives, and pushing the extremes. And you can go down that list in a rank-ordered fashion somewhat algorithmically, at least in the beginning, until
Mhm.
you get a bit more advanced. There's some advanced considerations, but that'll get you through like 97% of the time.
Of that quarter of the quantitative questions that you can use plug and play to
Yeah.
solve them quickly.
Yeah, you can't plug in on questions that don't have variables.
That's right.
But think about it, this one technique is applicable to up to a quarter of the problems.
Yeah.
That's a lot of bang for your buck.
That's right. That's right. And if you want to understand more, again, tune in to StellarGRE.com. Check Orion out. Thank you for being here this week, and we'll be back next week with another episode of GRE Bites. If you have another topic you'd like to discuss on a future episode, let us know, StellarGRE@gmail.com. Thanks.
Thank you.